So with that, we're going to move pretty quickly here into our first informational session. And, I'm very excited to moderate this. The focus today is on marine minerals exploration. We've got a couple really good information sessions coming after this and panels coming after this. But right now, we're going to hone in on marine minerals exploration. And Secretary Bolova said something about priorities for the administration and a really smart one, which is get ahead of emerging issues. That should be something when we get together as resource managers, academics, subject matter experts, we are really well set up to think about and contend with emerging issues. And we have some very bright people in the room today that can help provide some important context to this emerging issue. And so that's really our intent here. Many of you may know this is pretty timely for Virginia because, and not just for Virginia, really for the Delmarva region at large, there is some interest in mining for heavy mineral sands off the coast now. And that's something that even 2 years ago we weren't really thinking about or really contending with. So we're right on time, I think, in terms of creating a space to gather information and share that information. And again, that's kind of the goal. To that end, we have 3 highly trained geologists that will be sharing their expertise with you guys today. And I've had this experience just in the last couple days and talking to these folks, but if you ever find yourself in a conversation with 2 geologists, you'll realize that your training has not prepared you for that moment. They do speak a different language. It's a beautiful language, but what we have, collectively we're going to work as hard as we can to speak in a way that you guys can grasp that beautiful language. But it's really important because the geology really informs and is the structure that leads to the things that will either create a demand for this product and the potential for someone to mine this product or it not be there. So that really goes back to the geology. So today we're going to talk about that geology. We want to understand what's under our feet, what's on the continental shelf, what's below the continental shelf. We'll talk a little bit about some of the regulatory, economic, and practical considerations that might come along with this marine minerals exploration. But I do want to note that there's many questions right now about this. Far more questions than we are going to be able to answer today, most likely. This is still early stages. And so again, we're right time here to start really digging into this and sharing information. But it is a long haul, and we need to stay plugged in. We need to continue the kind of regional collaboration around this issue, and we will. So today we're gonna do this in 2 parts. The first part, we're gonna do a presentation. We'll have a small panel after the presentation. We're really gracious to have our first presenter in the room with us today and to have, again, his subject matter expertise. To kick us off, I want to invite Kerby Dobbs from BOEM, and he's going to present some information about his program at BOEM, but also how they manage mineral leasing and really provide some important high-level context that I think will be instructive for the panel to come. And with that, let's have a round of applause for Kerby.
Thank you, Ryan. Thank you, Secretary. It's a very humbling moment to be in here amongst you guys, and I really appreciate the invite. I'm a local guy, and it's nice to speak at a meeting that's closer to me than my office is. So, marine minerals, it's a big topic, but it ultimately comes down to a conversation about sediment. So today we're going to talk about what the Bureau of Ocean Energy Management Marine Minerals Division is doing to help you guys and all your coastal communities remain resilient. And I've also kind of chopped that up a little bit to capture some more of the greater themes in the marine minerals realm. Okay, so Outer Continental Shelf Resources and Activities. It's a big space. Our EEZ, our continental shelf, it's bigger than the continental U.S. landmass itself. So a few of us managing a big space. Historically, the Bureau of Ocean Energy Management has done oil and gas leasing, renewable energy, we all know where that stands, and sand and gravel leasing for beach nourishment. But now there is an emerging use, another potential major player using the seabed, perhaps a once-in-a-generation occurrence, and that's kind of concerning everybody, so we're trying to position ourselves to best manage that resource. So, quick overview of critical mineral resource demand. You could kind of group everything into two categories. One is deep sea minerals, the other is coastal minerals. The deep sea minerals, you've probably heard of polymetallic nodules, polymetallic sulfides, and cobalt crusts. Really, what does that mean? It means there are metals and elements in those minerals that we use for solar panels, batteries, technology, mostly batteries. So we want more energy, we need more minerals. Coastal minerals, phosphorites and heavy mineral sands. Phosphorites, they mainly are targeted for phosphate, for fertilizer, and then some rare earth elements that also factor into the technology equation. Heavy mineral sands, the primary elements of interest there are titanium, zircon, and a few other minerals, mainly for industrial applications, material science, white paint, golf clubs, for example. Okay, so knowing that these are what the demand is potentially for, where do they occur, and kind of what does that look like? Not sure why that map's coming up, or not coming up. Deep sea minerals, they're all in the deep sea. They're all kind of way out there in the middle of the ocean. Just picture the middle of the ocean. Most of the demand for the deep sea minerals is in the international seawaters, seabed. That has yet to come to fruition. There's still a lot to figure out there. I think for us, the main concern is the unknowns environmentally, just on a global scale and on a local scale, kind of what happens there. But in terms of multi-use conflicts, not a whole lot of multi-use conflicts in the middle of the ocean. So coastal minerals, they occur near the shore, not to imply that they're only occurring near Maryland and Delaware, but Laura's going to show a really good figure later that's going to show you where they are. Okay. Oh, all right. We got a little click. I guess I'm better at PowerPoint than I thought I was. So yeah, there's the map, all the bright colors. That's where all of the occurrences of the deep sea minerals are. You can see not many that are coastal, not many in the US EEZ. Okay, so coastal minerals, coastal heavy minerals, that's sand. Heavy mineral sand is sand. It's no different than the sand that you and I play on the beach. This graph on the left is a graph of beach nourishment sand volume over the last century. You can see we're not slowing down at all. We need more sand. Where are we going to get that sand? And essentially, the folks that want heavy mineral sand, they're targeting the same sand that you and I both use for the beach. So it sounds like there's a potential opportunity there to have some co-benefit, co-use, perhaps. So what is the Bureau of Ocean Energy Management Marine Minerals Division doing to help address this? We're choosing research themes that sort of are durable. They have multiple applications. They're kind of interest to everybody. The first one is supply and demand. So really, how much sand do you need, and for how long do you need it, and how much sand do you have available to you at this time? The first graph there on the upper left of those four, that's Dan Warner's recent research that we funded. He modeled all of the mid-Atlantic beaches all the way out to 2100 under multiple different climate scenarios. So we have a pretty good idea, or roughly, how much sediment we could potentially need over the next 75 years. It's a freaking lot. Resource evaluation and geologic framework studies. That's really mapping out where the resources are and what they consist of. I think that's like the foundation of mineral science and geology and mineral resources. BOEM, we fund reconnaissance level or exploration level research that kind of points communities to the resources that they should be more interested in, that they should investigate further, that they should turn into a borrow area for their coast. Risk mitigation. studies that inform how to manage the resource in the least impactful way possible. That could be monitoring dredge pits, comparing that to control areas in the vicinity, and determining, what is the long-term impact of our dredging on either the water column, the benthic communities, the fish, all that good stuff. We've got a ton of research going on for that. One of our recent cooperative agreements here in the lower left was with the University of Florida, and it was a multi-volume study over multiple years. All that's published on our webpage. I've got links for all this stuff at the end if you guys are interested. And then resource optimization. So anticipate the effects of sediment removal and placement, maximize efficacy, minimize losses, reduce and eliminate waste. And that last one's a big one. There are heavy mineral sands that have tremendous value. Sand itself has tremendous value as aggregate for construction. We want to make sure that we're not wasting any of that material. We're not just sending you loose in the sandbox and digging and, rucking up the seabed and putting it on the shore. We want to make sure we're getting the most benefit out of that use. So those are the main research themes. One ongoing study that focuses on resource evaluation is this has taken place over a couple years, a lot of stakeholder engagement, review of existing data, where were data gaps, where was the greatest need on the coast. We ultimately settled on two areas, one offshore of southeastern Virginia, the other offshore of sort of central and southern New Jersey. The red lines on those maps are geophysical track lines. The orange dots are planned sediment coring locations. We have a contractor out in a boat as we speak, drilling holes in the seabed offshore the Chesapeake Bay. Don't worry, they're not deep ones, and they're to help find your sand. But this location off of Virginia, we're hopeful that the findings of this will pretty much help determine how much sand is potentially available within an economic distance of Virginia's Army Corps coastal resilience projects. So at the end of this, we'll pretty much know how much you have for the long term that's reachable with the normal amount of dollars that you have for a resilience project. Coastal New Jersey, this was in part to follow up on some work that we did in 2015 offshore of Absecon Island. We had some unfinished business there, and it was also advantageous to go there because the wind lease areas are really constraining, what is available to them on that part of the coast. So going back and following up there, and then the area further offshore that's kind of directly off of Barnegat, major area that's been very underexplored for sand and gravel. It fills a major data gap between two public data sets and two areas that are extremely rich in private sector data that nobody will see for a very long time except me and my colleagues. So a lot of new data there to become available. This study is concluding in September, and our goal for all of our research is as soon as that period of performance day ends, that stuff is ready and it's published on our website within a couple weeks. Last slide, that was some stuff that we had going on, and this is what's happening right now. Okay, going to switch gears a little bit here and dive into the BOEM regulatory framework for commercial leasing of seabed minerals. This is just going to be a quick 101. So the first step is normally prospecting, just like in any mining operation. You would come to us, apply for a permit. It doesn't cost much, but the permit is to go out and do some research, collect some data, sort of find the areas that you might be interested in mining. And then typically the next step is we have a lease sale. In some cases, we have a party come to us and request a lease sale that's unscheduled. So out of the blue, they just kind of come and request a lease. Typically, when that happens, you would think they have prospected quite a bit and they already have their eye on some very specific locations. Sometimes that doesn't happen. The change in priorities of the administration has caused folks to kind of get up off their feet and I would even say jump the gun. But This is a multi-year process, so it's not something that just happens overnight. And then once the lease sale happens, there are activities that are sort of approved and monitored under a lease. Right now, the agency that monitors all that, makes sure they're compliant and safe with their operations, that's the Bureau of Safety and Environmental Enforcement. That is the Bureau of Ocean Energy Management's sister agency. I don't know if any of you guys heard about this, but the administration wants to combine the two into the Minerals Management Administration. That may sound weird, but we used to be combined back in the 2000s and before we were the Minerals Management Service. Then Deepwater Horizon happened. They split us up for kind of checks and balances, and then now they're talking about recombining us. So we'll see what happens there. Regulatory pathway for OCS mineral leasing. This is just an expansion on what happens when a lease is requested or when a lease is scheduled. The first thing that happens, and this is kind of where we're about to be, is a request for information and interest. This has yet to be published in the Federal Register for the lease that was requested offshore of Virginia. It could be any day now. For all I know, it could be happening at this very moment, but I haven't checked my email in 2 days, so I don't know. But that's coming soon. And then after that, everybody kind of weighs in. That's when we gather all the information that we need to help determine where that lease is going to be offered. So where that lease is going to be offered, that's area identification. Then we go through all the NEPA consultations. That's, I'm sure all of you are familiar with, multi-year process, no stone unturned. And in this case, it's focused on activities that are permissible under the lease, not the actual operations. So there's more NEPA that comes after that. Then there's a proposed leasing notice. Then an actual leasing notice in the Federal Register. Like we talked about yesterday, it'd be nice if there was a dashboard that would alert us when new things are proposed in the Federal Register. And then there's a competitive lease sale. So the party that requested the lease, they might not ultimately get the lease. There might be somebody else that comes in and competes with them for that. So that's kind of it for that. So kind of looping back, we're sticking to our key research themes. That kind of keeps us durable no matter what happens with commercial leasing, no matter what happens with the administration. These research themes are not going to change no matter what's going on. These are the things that get us what we need. So we need to be doing long-term supply and demand for sand for your coast. Resource evaluation, always need that. Risk mitigation and resource optimization. Understand the trade-offs of multiple uses in the same space. Everybody just wants to put their flag in the sand and claim their space, stay away from my space, but I think there's a lot of opportunity for co-use and co-development that we're not really thinking of because, we're just so bandwidth limited that we just have to stick to what we know. So again, more mapping, promote recognition of sediment as a finite resource. Your sand has value. Don't forget that. It's not just free sand that we put on the beach. It's, at Four Seasons Landscape Nursery this weekend, it was $60 a cubic yard for beach sand. Pretty crazy. So balanced stewardship and interagency collaboration. That's what we're doing here, so we're kind of already doing that. These are the links and the references to the stuff I put up there. All of this can be accessed on our Marine Minerals Information System viewer as well. And thanks.
We're going to do questions for Kerby right now. So just want to open it up for the audience here, and we'll have some mics running around, I think, as well. So take a minute. Anybody have questions burning off the top of their head? I can ask a question. People are still thinking. There we go.
Oh, I'm Sadie Call. I'm representing the public for this question. So you said for the activities under a lease, there's environmental protections. Do you have those set yet? I'm kind of wondering that.
No, they would generally fall under the typical NEPA suite. We have a sand survey and sand operations environmental assessment that we it's like a programmatic EA that we stick to for all sand dredging operations. And the operations that would likely take place under this heavy mineral lease are the same operations that would take place for dredging for a beach nourishment. So those mitigations are generally already in place and understood, but we would develop new ones if we had to.
Thank you.
We have a question here.
Good morning, thank you. I'm from New York, specifically Eastern Long Island, specifically Shinnecock Nation, where our life depends on the water. And any erosion diminishes our country's territory. Any comments that we should, relevant to what you just told us, anything about New York that you can tell us? The New York coastline?
In terms of prospectivity for that type of mineral?
In terms of the value of the sediments we have there, we're doing a lot of beach nourishment, as they call it. So I think there are two questions. One is beach nourishment, but the other is builder knowledge. Every time we build more, and we do a lot of that on Long Island, what's happening in terms of that impacts what you're talking about here, availability. And maybe even more specifically, are there particular minerals that we need to be concerned about in that area?
Well, that's a very good question. And in terms of specific minerals, heavy mineral sands, I would say that's probably not a big thing for you guys, but one thing that really lights up for us when we think about Long Island, New York, is just the magnitude and density of multi-use conflicts. So Western Long Island, offshore of there are so many cables, so many disposal areas, so many shipping lanes, so many, just everything. It's one of the most congested areas probably on the eastern seaboard. Very few areas to dig for sand without the potential risk of running into something else. So for long-term Long Island, it's absolutely critical that you guys find all of your sand. There's a lot of it, but find all the sand that you might need. At a minimum, understand how much you might need in the long term, and work with developers that are removing sand and placing it elsewhere as part of their site development practices. So when you install a cable that's associated with a wind lease area, they prepare that corridor by moving all the sand waves and flattening it so their tools can be more efficient. In some cases, that's tens to hundreds of thousands of cubic yards of sand. And we had a couple instances that they were willing to share that sand with the community as part of their site development process, but the timing just didn't work out. And it never came to fruition. It happened too fast. Thank you for the question.
Hi, I was curious, you put up the regulatory framework, if that'll be impacted by the executive order for unleashing critical minerals. Will that speed up that regulatory process, or how will that impact that framework you had up there?
I can't speak much to that, but there were some proposed modifications to the rules for commercial mineral leasing. From what I understand, that really hasn't affected the NEPA process. It may have expedited the timelines for, the things that lead to a lease sale, but in terms of NEPA and, where the coastal zone management programs in each state factor into that equation and the information that's shared with them when that process begins, nothing has changed.
We have a question online. I just wanted to respect that really quickly. I know we have a bunch of questions in the room too.
Yeah, thank you. Hi, everybody. Gabby File from NOAA. I just had a quick question. So in offshore wind, we've seen how the expedited timelines, they can really compress that environmental data collection, which created challenges later during things like the EFH consultation. And given that mining timelines are similarly expedited, if not more so, I'm just curious, how is Bowen planning to ensure sufficient baseline characterization occurs before that mining process begins?
Well, let's see. The first thing that's going to dictate what happens in a mining area is more prospecting, so just more data collection in general. And while you're collecting, geotechnical and geophysical data, just as part of that process, you can collect more environmental data. So sort of alongside the prospecting, you will have more environmental data, but I can't speak to the actual timelines that may or may not be compressed.
So
Question in the room, guys, but I promise there's going to be more opportunities to ask questions of the other panelists that can speak to some of this, and then Kerby might, answer from the audience as well if he feels inclined.
Sure.
okay, thank you. Tony McDonald, I'm from New Jersey, so very relevant. Kind of a two-part question. One is, and from the NOAA, building on the NOAA thing, is NOAA is also now, because of the deep sea mining, they're sort of running it at speed to develop standards and criteria for mining in the high seas. And just wonder the extent to which, again, I do think there is a lot of interest in the geopolitical world in general to expedite permitting in some way, or at least make it very predictable. So I just wonder the extent to which you're seeing your standard process more pressure to sort of, not pressure, I mean more interest in expediting the permitting framework. And then, again, it's a little bit of follow-up on the last question. Sometimes I feel like the business interests are, this has been a public asset, right? I mean, the thing, this sand has been traditionally thinking of, this is the public trust, right? So this is a public asset. But increasingly, I'm concerned that the investment in the corporate side, whether it's green CDR or mineral lands, that they're so far ahead, and it's hard for the communities and the science community to keep up with that kind of information. So any thoughts about how the current interest, not only in this administration, but also in private industry, in coming into the ocean is changing the equation from the way you've done business in the past?
I can speak just a little bit to that, and I guess that's going to be the last question before the panel. But the big thing here with this type of mining and the interest in heavy mineral sands, the major unknown is how the economics will shake out. And the economics for any mining operation are obviously the only thing that matters. So until we suss all those economics out, we may find out that the economics just don't pan out. There might not be enough cooperation or just enough capacity in the marine supply chain, or diesel prices might totally price out any dredger in this type of prospect. So a lot remains to be seen there.
All right, how about a round of applause? Safe travels, Secretary Bulova. Thank you so much for your time again. Well, I can tell there's a lot of interest and questions in the room, so don't fret. We're going to make sure that the audience gets the majority of the time here with the panel in terms of driving these questions. Do keep in mind they're geologists, but I think it's fair to, so when we get into the regulatory and permitting framework, they may not be able to engage on that too much, but what's important, I think, is for us to hear those questions, collect those questions, understand where the audience feels we need more information, and that's where Marco and the Mid-AOPC can step in and start to help fill some of those gaps in between our, this meeting and next meetings. So with that, I'm going to go ahead and invite David and Laura. You guys can go ahead and come up and sit down, then we'll do our formal introductions in here. But let's all be up here. Let's hang together. This is a small panel, so you're going to get some rapid fire opportunities to dig in on these geologists, excuse the pun, we're just tremendously happy to have them here today. I want to start with Dr. Laura Brothers, and she comes to us from USGS. She's a marine geologist at the USGS Woods Hole Coastal and Marine Science Center. She studies how the seafloor and the earth beneath the seafloor change with time and major events, and from the shores of the Arctic, Gulf of Maine, Mid-Atlantic, and to the deep sea. And I think what's really interesting and critical here is Laura has helped us to understand the geologic framework in this region, and that really does contribute to our understanding of things like the presence or the non-presence of heavy mineral sands. So, Dr. Laura Brothers, I'm going to turn it over to you. Thank you so much.
Hello, thank you all for having me. So glad to be here. Ryan, thanks for organizing this jazz. Secretary Kerby, thank you for giving a great talk. And let's get into it. So it's David's talk, but I bet it's really good. But it will be better.
Close your eyes, people.
It'll be better if David gives it.
No spoilers. How many slides? Oh, there we go. You get some animations in there.
All right, this one's my speed. Okay, and so I'm going to give kind of a broad overview, and I think you all are coming to this and those great questions that we just had. I'd like us to think about, prove why this title of the talk is true. Heavy mineral sands, so hot right now. Okay, the central problem is that we are building lots of things on our seabed, and we want things from our seabed, and we would like to protect things on our seabed. And we want to do all of this more, but we don't know where all the hazards and where all the resources are. Okay, and why don't we know these things? It's because most of the nation's continental shelves have not been mapped with modern methods. So we have data, a lot of data available in some places, then other places, no data. Okay, so it's splotchy data coverage, and there can be different silos and stuff to share sometimes. I think Vicki Farini probably really covered this very well yesterday, but there's a lot out there that we still don't know. Another problem, there are some types of minerals that we extra care about. And so these are the minerals that are designated critical minerals. And so these are minerals, just like Kerby outlined, that we use in most of our technology. And to get on this list, in addition to being really needed, there might be some vulnerabilities in the supply chain. They might be hard to get for some other reason. Okay, a solution, question mark? Maybe heavy mineral sands. And so this is similar to photos that Kerby showed, and I'm just gonna, and looking at this image, you can see these banded layers, and the dark layers, this is from a beach, I bet you guys are familiar, are the heavy minerals, okay? So the heavy minerals, we call them that because they're denser than the other minerals around it. They sort out in different processes, like swash of the waves coming in and out, and that's how you get these different layers. And sometimes these heavy mineral deposits have critical minerals. Not every heavy mineral, not every dark mineral that you see out on the beach is going to have ilmenite or titanium, zirconium, but some do. And this is a map. It's from 1987, but it's still kind of the best we have out there on where you find the highest concentrations of heavy minerals in the continental shelf. And so the map is old. I'd like you to focus on kind of the darker black blobs on it. Those are the areas that have the highest concentrations of heavy minerals in the sediments. And one blob in particular is right off of Virginia. And so this is a map. This is a great map that David Hawkins and Michelle Nelson and the other great folks at Virginia Energy made. And those little dots there are where they have sampled the seafloor and have examined, are there heavy minerals in that seafloor and what percentage. The warmer colors, the red colors, that's your highest concentrations of heavies right there. Okay, and something I'd like you to notice is that most of the highest concentrations of these heavy mineral sands are at the mouths of major rivers, kind of throughout the country, okay? That's because these minerals come from the inland deposits of igneous or metamorphic rocks and are transported to our continental shelves by rivers. And then they get concentrated in types of beach environments. And so a possible solution to kind of understanding what's out there and what we need to either examine more or protect is to know more about our regional geology. And so the image On your right is a map of data collected by the USGS and NOAA, and it gives an idea of what the seafloor sediment texture. That's what we call, if it's sandy, is it muddy? In this area, I have a couple of pictures of how it is sandy and sometimes has a lot of seashells in it. The other image is a seismic reflection profile, but I think of it like a layered cake. It's like if you slice the seafloor and you could see layers of sediment or different activity, time underneath it. And so when we look at the geology, we want to know what's on the seafloor and what's below it. So how do we do that? Well, we want to collect information that can be used for a variety of applications. And so today we're talking about heavy minerals, but we could be talking about habitat, we could be talking about paleo landscapes, we could be talking about what seafloor would be most stable if you were going to put a structure or foundation on it. So to do that, we do a lot of seafloor mapping. So we're putting sound into the seafloor, and depending how that sound returns to the seafloor, we can get an idea of what the composition of the seafloor is, and are there any layers or structures beneath it. We use these layers, we sample the seafloor to start to get an idea of what is out there, what are the characteristics of the seafloor and subseafloor. Now this work is expensive. You have to do it on ships, it takes specialized equipment, and it takes a lot of people. And so for these reasons, it hasn't been done everywhere in the United States continental shelves in a super systematic way. Okay, so what do we have off of Virginia? What's Virginia's geology? And so again, here's a picture of what, if you slice the seafloor, what it would look like. And one of the things you may see, excuse me, excuse me, the granola was delicious, and it's just a little bit, is that if you're looking at this seismic reflection profile, you can start to see some little U's, V-shaped concave reflections in there, and those are evidence of ancient rivers, creeks, that were going across what is now the seafloor, but back in time, that was land. All right, so these paleo channels are rampant across Virginia. As time went on, sea level rose, they got to be infilled with sediment as the ocean came in. Okay, so if we have this information, we can go through and trace a layer, like if you mapped all the layer of a cake, and we get an image like this. And so, sorry, it might be a little hard to see. We have Fisherman's Point at the left side, and then you have the map ends at about Ocean City on the right. And so this is the Delmarva Peninsula, and what we're looking at, things that are in blue, those were water. So we can start to see paleo inlets in this area, and ancient rivers. And I'll say some of these ancient rivers, the one on the left side, that's the ancient Susquehanna, that goes right to Norfolk Canyon. And so these are all environments that either transport heavy minerals, lots of minerals, and can even focus those mineral accumulations. Further, so this is another map of the same area, and these red, orange, yellow, green kind of squiggles, those are ancient iterations of the Susquehanna River. We know that the Susquehanna River crossed over the continental shelf several times in the past million years. And so lots of opportunities to bring minerals, materials from inland across our continental shelves. And just like Kerby was getting at, this work is informing what's going on right now. As you all know, there was an unsolicited bid for mineral leasing offshore Virginia. And so for the first time in over 30 years, BOEM is addressing any of these potential leasing in this area. And so this is the type of geologic information that starts to be able to inform what kind of studies are needed for either prospecting or regulation or just knowing what's out there. So my conclusion is geology is important, okay, and it can form lots of things. And I'd like to end with the image of what we think the Mid-Atlantic looked around 20,000 years ago. And so the green is land, and where it's blue, those were rivers going into the ocean. All right, and that's all.
Thank you so much, Dr. Brothers, and I really appreciate your ability to convey this, obviously highly technical information in a way that I think really connects. Hopefully, there's layer cake for dessert today to really drive that home. All right, so I'm excited now to invite up our next speaker. And, again, after we do these two presentations, we're going to open it up to questions. I've got a couple questions, but I really do want to reserve most of the time for you guys to ask the questions that you have. We want to know what you don't feel you know enough about. We want to know what you want to learn more about. And so this is a great opportunity to do that. So I'm going to introduce David Hawkins, and he's a geologist at the Virginia Department of Energy in the Geology and Mineral Resources Program, and many states have a geological survey, and they serve as our geological survey. And so he collaborates with federal state partners to conduct mineral and aggregate resource investigations across the Commonwealth. They do this onshore as well as offshore. And in fact, Virginia Energy, in collaboration with BOEM, really were ahead of the curve on thinking about some of the heavy mineral sands considerations offshore Virginia. And so they've done some work on this for years now. And so he'll be able to talk a little bit about that. And also close to our heart here, David is one of our members of our Virginia Coastal Policy team, a very active one who has for a long time been with us to help support our understanding of these things and bring great project ideas that really show us how impactful geology is on the current forces that we're trying to manage in coastal resources. And they really are the closest thing to time travelers that I think we have here. These geologists that can look back millennia and say this is what it looked like. That's a real treat. All right, so with that, I'm going to introduce David Hawkins to tell us a little bit more about the Virginia side of this scene.
All right, thank you, Ryan, and thank you, Kerby and Laura, for giving a nice introduction on some of the big picture items in geologic framework. So I'm going to talk more. I'm going to bring it into Virginia specifically and some of the work that we've done really over the last 40 plus years, but more so I'll talk more in detail about the work we did in the recent years. So as Ryan mentioned, we're part of the Virginia Department of Energy, and my program functions as a state geological survey. So we do a lot of work with other federal agencies like the USGS as well as BOEM and NOAA. So we really are the repository for geologic data, for digital data and physical data for the state. All of the information that we generate is publicly available. So I'll take you to the barcodes on the side of the right-hand side. That can take you to our website where we have a lot of our information and outreach available, as well as projects, as well as our offshore sands webpage where we host a lot of our reports. Just a quick acknowledgement of some of the funding sources that have generated some of this work. We've had a few cooperative agreements with BOEM, and I'll talk more in detail on the most recent one, as well as the USGS for some of our onshore studies, and I'll briefly mention some of that. And then, of course, my co-authors, Michelle Nelson and William Lassiter, for the most recent cooperative agreement, really pivotal in getting that information together. So Kerby provided a pretty good overview of what heavy minerals are, so I won't really spend a lot of time on that, but just to kind of put it into context for Virginia, what we're talking about and how it relates to some of these offshore minerals. So heavy minerals, as Kerby mentioned, are basically part of the sand size fraction of sand. So in the very fine to fine sand, generally, they are basically called heavy because they have a density that's greater than quartz for the most part. Ilmenite and zircon are the primary ones of interest. These are titanium-rich and zirconium-rich minerals used for different applications. And the one thing I want to point out is that these do occur in active mining on land-based deposits in the fall zone. So these are old paleo shoreline deposits when there was a sea level high stand. So kind of south of Petersburg and Richmond area, there is a deposit there that's been mined for over 20 years, and it's generated over $1 billion industry for Virginia in that time period. So similar to the modern coastal setting, just an analog from basically millions of years ago. And then to a lesser extent, I won't really talk about this much in our presentation, but phosphate is also mined onshore. Not in Virginia, but there has been some prospecting done in some of the older marine units. The phosphate is mined in North Carolina from a well-known site, as well as Florida. So there is potential in Virginia. It just hasn't really been characterized to the full extent. I think a lot more subsurface investigations would be, wise to do that. And also the unit that the phosphate occurs in is an older unit that is in the subsurface of where it is exposed in Virginia. So, I'll talk a little more about how the geology plays into that. And one quick thing I want to mention before I move on is that the heavy minerals, as far as co-extraction and separation, are relatively simple. It's just gravity. So if you think about running stuff into a slurry, you're separating out the heavier and lighter minerals. It's a relatively simple process from that standpoint. So a little bit about the geologic setting. The image on the left is a simplified geologic map of Virginia, kind of going from the eastern Piedmont, where you see those purples, going into the coastal plain with the yellows and oranges. That's pretty much just a layer cake, as Laura mentioned, of unconsolidated sands, gravels, and clays, and it continues offshore as well into the continental shelf. Some of those paleo drainage vectors are also shown there from some of the ancient drainages. And then if you look at the right, this is a cross-section, kind of 2D view looking into the subsurface. You can see that how those, the coastal plain layer cake sediments basically dip to the east at different angles and whatnot. But the take-home is that some of these units that they're targeting for phosphate, for example, are relatively deep in the subsurface offshore. The other thing I want to point out is that mining, the deposit that's mined on land that I mentioned, is at the fall zone. So, the material there is slightly different than what's being considered offshore because it's closer to source rock and source material. So there's slightly different makeup in the elemental or in the mineral content. Hopefully you can see this fairly well. This is a digital elevation model basically showing the topography of the lower Chesapeake Bay entrance and kind of showing where some of these modern coastal systems exist as well as some of the older ones. The image in the upper right is kind of another 2D view of modern coastal features, dunes, barriers, modern beaches that kind of show how the heavy minerals may be either concentrated by wave action or swash zones as well as disseminated in the material. So I mentioned there's an old, it's really hard to see, I apologize, but an older deposit. That orange line kind of represents some of our paleo shorelines. So at different stages, these were the shoreline at that point. So we can have heavy minerals occur there just based on the fact that they occur geologically at these beach settings and nearshore settings. Of course, we have the paleo drainages that deliver the material from the source that continue offshore as well. And then the modern beaches and coastal systems, which are dunes, beaches, barrier islands as well. And then the modern channels and shoals that are out there that are kind of reworking some of these deposits. This is an interesting photo I took about 4 years ago. This is Virginia Beach, probably 10th or 9th Street. Just happened to dig into the sand a few inches, and that's what it looked like. So this is, as Laura showed, it occurs in these kind of laminae in the sand, but also there can be areas where it's concentrated. And just want to note that this is material that was, dredged offshore and brought onto the beach as part of an earlier nourishment. So we know that it is there. It's just, how much and where is it concentrated potentially. And then quickly, I won't really talk about this, but this is just kind of another conceptual seismic diagram that Laura alluded to, basically showing that the offshore environment's mostly modern sand over some of these buried Pleistocene and older features. So quickly, overview, we've worked with BOEM for decades, well before I came on to the agency 5 years ago, but we've done a lot of investigations offshore, getting grab samples, core data, seismic data, collaborating with USGS as well as the Virginia Institute of Marine Science and other state agencies, and they help us to understand the framework and obviously where some of these modern deposits occur. And these have all mostly been focused on the federal outer continental shelf, but we do have some state data. So kind of tying it into Virginia specifically, my predecessors before me did some work looking at the two main borrow areas offshore, Sandbridge borrow area, which is right offshore of Sandbridge and Virginia Beach, as well as Wallops Island. So they did kind of a regional level estimate of sand volume resources there using seismic data as well as vibrocore data, and basically looked at how much beach compatible sand is there. And that's basically sand that's fine and medium grain that has low shell and opaque content and gravel content. So this varies by location and use. Obviously, the Sandbridge is a very different use than Wallops Island, so the material specs might differ. But you can see from this heat map that the areas that are more yellow and red might be more conducive to host sand volume. And you can't really see it, but the lease areas are also shown in the red polygons kind of in the upper parts of those two areas. So then the most recent co-op we did, which I think kind of ties together some of the stuff we're talking about today, is we did basically a cooperative agreement to look at what we called it a capacity assessment, just kind of look at it, do a large desktop review as well as collect new data to see how feasible this may be a scenario. So actually 4 years ago we hosted another forum virtually. I think a few of y'all were in attendance on that, and it was pretty much asking the same question, how feasible is it to get these heavy minerals from the sand that's used for beach nourishment. So there's a lot of cool takeaways from that and a lot of things that we don't know that we can definitely talk about more in the discussion. We also collaborated with Schnabel Engineering to get some archived vibro cores. So this was a good opportunity to leverage industry partnerships. They had these cores sitting in a warehouse that they weren't going to use anymore. So we said, we'll take them and process them. So we were able to run these cores through that gravity process I mentioned that we call it a spiral. So we were able to actually get concentrates and then send that off to a lab for more detailed analysis and look at what the actual makeup is of a borrow area that's being used for nourishment. And the question was, can that offset dredging costs for a municipality? Because some of these municipalities, specifically Virginia Beach, for example, spending, tens of millions of dollars to do a nourishment project, and they have to cover that bill. And we also compiled that 40 years worth of data into a single location, a geodatabase, and that's really valuable because it basically puts all of, this data consists of different types of sediment, different sample types, and we have all the references to that data there so you can kind of see it all in one location. And then another thing we did that's kind of new is we outlined a screening protocol with a portable X-ray fluorescence analyzer, and this looks at geochemistry of material to kind of inform potential mineral occurrences. So it's kind of a quick screening tool that can be used. It's commonly used in the environmental field for contaminant assessments as well. And then, of course, what are the next steps? What's not known? What needs to be known? I won't really go into this much, but this screening protocol I mentioned, we did, we worked on this for a while. We looked best practices from literature, how do you prepare the material? How long do you run it? And just for a context, this is basically a non-destructive method that's emitting an X-ray into a sample that's causing spectra. It's basically causing electrons to come out of the shell. I won't get into that, but it has certain signatures that you can associate with elements. So if you see there's an enrichment in titanium or zirconium, then there might be ilmenite or zircon in there, for example. So the question there is, can we use geochemical elements as a proxy for mineral occurrences, specifically for these type of materials? And we're also doing this for other projects, looking at rare earths and different types of clays and sands. So a few more slides. This here shows quite a bit of stuff, but I'll kind of work my way from left to right. On the left side, we have a contour map of those point data that Laura showed with the heavy minerals from like 600 plus samples. And it's really hard to see, but those pinks and purples that are darker, those may align up with some of these paleo drainage locations. So is there some influence there from that input, as well as some of those other shoaling areas along the eastern shore? The image in the middle shows our sample locations from the Sandbridge Barrow areas, as well as the Federal Atlantic Navigation Channel. So if you've been out to the ocean front the past few days, you've seen ships going through that Atlantic Channel right there. So these were what we were able to kind of beneficially get samples from the previous work done by Schnabel for characterization of that Barrow source for nourishment specifically. The pie chart shows the typical makeup of those elements, so mostly ilmenite, no surprise, and a little bit of zircon and rutile. It is a little less of these constituents compared to the fall zone deposits because, as I mentioned, those are closer to the source of the material, so closer to the metamorphic and igneous rocks that are actually providing that. So to kind of go through this, we have varying different degrees of total heavy mineral percentages of the bulk material, but I'll focus mainly on the Sandbridge Barrow area because that was that was kind of the focus of this project, and it averaged about 0.85%, so about almost a little under 1% total heavy minerals, which doesn't seem like a lot, and it is low grade. But when you take other things into effect, like the onshore deposits that we've done studies on are similar, 1 to 2%, and some of the ore grade deposits are about 4% at the lowest, so it's really not that far off. So now to kind of put that into context and like, well, why does that matter, or how can that be economic potentially? I'm going to try to walk through this without getting too confusing. So we know that Sandbridge, that's on every little line. has about 1% total heavy minerals, and this is based on reconnaissance data. These points may be a mile apart from each other, so by no means is this really a reserve estimate or anything of that nature. But if we look at commodity prices for certain minerals in the U.S. based on census data from basically import data from duties, this is assuming that you have a bulk material of 100% ilmenite, 100% rutile, and zircon, vice versa, and that's how much it would be per cubic yard. So we're looking at prices of $400 to over almost $2,500 for these mineral commodities for a cubic yard. However, if we look at the makeup based on that pie chart of what's actually there, these minerals are about 54% of that specific area. So then we have to adjust that. So then you're looking at about 380 cubic yards, $380 per cubic yard, assuming you have 100% heavy minerals. So why are we looking at that? We did basically a kind of a rough resource estimation using some of the estimates from Schnabel. They said there was about, I don't have the numbers on me right now, but 10 to 15 million cubic yards of sand suitable material from their investigations for the beaches. And if we take that or if we take that 0.85% of that, or I'm sorry, we take, let me go with the next slide. 0.85% of that, it's 243,000 cubic yards of total heavy minerals for that huge area. And that can equal about $92 million. This is very hypothetical. This doesn't take into account the economics, as Kerby mentioned, but it's a good starting point. So what about a typical beach nourishment project? Well, this is a little more than some of the recent ones, but say you have 2 million cubic yards of sand dredged from that source. Taking into account these prices, that 0.85% and that 54% makeup, you have about $3 a cubic yard of just these minerals alone. And this is, like I said, 54% of that total heavy minerals. There's other valuable minerals in there, but I just wanted to kind of focus in on these. So a project of 2 million cubic yards of sand, assuming this general 0.85%, could be about $6 million worth of value there. And that's about 30% of the cost of, if the project was about $20 million, for example. However, there's many assumptions. There's a very high level of reconnaissance data. As a state survey, that's really what we're working with. This is all publicly available data. We're not exploration companies, but we are there to get the data to provide information on mineral resources. And also, this is based on a large volume of material. So the idea behind this study is you're using beach nourishment material that's already being pumped onto the shore to get potentially a co-beneficial product. Upfront costs can be significant. We do have, industry has expressed interest. Virginia does have an industry, as I mentioned, and they are looking for potentially other streams of material to process in their gravity facilities. So, there are economic incentives, but the upfront costs could be, more than $100 million to get something going. So a lot of unanswered questions still at that scale. And then I mentioned, is there an existing industry that can handle that processing? And in Virginia, we do have an existing industry. However, it's 300 miles to the west. So. And I'm out of time on this, but just quickly, the opportunities and challenges, obviously co-extraction versus mining, these are kind of different concepts, and we focus on co-extraction as a mutually beneficial, product. You're dealing with a large amount of material versus mining, you have to know where you're going, so that's why the economics are very important, or it may not happen at all. Technology is demonstrated on shore. Pilot testing, I think, would be very useful to really look at this in more kind of under more of a finer tuned scope. And the upfront costs obviously can be significant. Is there interest? And how does this play out for municipalities? This is kind of conceived to help them, with that, to have some offsets. But, how does this look from, where this is occurring in federal waters or state waters as well as for localities? So, and then we also have to think about the transport, disposal, and handling of these concentrates. I mentioned these are gravity concentrates, so you could initially just have something that's already being sorted during dredging process and then further separated on shore. And as Kerby mentioned, this is sand, but when you concentrate certain heavy minerals, you do have a different product than just beach sand. So those are things that need to be considered in the environmental process, the NEPA process as well, and what other regulations are missing, because as a state, we mine non-fuel minerals onshore, but we don't do it offshore. So in very limited cases for like river areas. And I think we'll take questions as a panel, but that's all I have for now. So.
Thank you so much, David. So I'm going to rapid fire here, just a question or two, but we don't have a ton of time, and I want to make sure there's time for you. So do be thinking of your questions, try and keep them quick and concise, and we're going to try and extract as much information from these poor geologists as we can. So real quick, just because Marco and Mid-AOPC is in the business of trying to understand data gaps and work on those data gaps at regional and local and state scale, could you guys speak, briefly about what you see over the next decade as the most important research in your domain that you think needs to be tackled, whether it's something you plan to tackle or you think might be tackled otherwise? And we can go to Laura first and give David a little respite here.
Okay. Oh, good. Okay, that's good. Yeah. So, in general, if I would say what should we do next, I think having the folks in this room and working towards looking where don't we have data, where do we need it, how would we integrate that with what we already have. That's what we should do. And I will say things are already getting better that way with forums like Marco and other regional forums, and having the voices too, that we can share the information and make much more strategic investments in research where the data are public. That can be used for what the many different interests that we have. So that's not say I'm not giving a specific area that we should go for, but if you didn't see any lines or dots on the maps that we've been showing, we don't know what's there, and so you've seen some gaps already. And so thinking of how we can address those and leverage our resources, because like we said, this is expensive work and we want to get the most out of it that we can.
Yeah, and I think, connecting with your state geological service is a paramount importance, and I think most states are already doing that. Coastal zone programs, you should have those conversations too if you're not. So that'd be a great way to work together to find those gaps more locally. So David, on the same question, in general, where do you see in the next decade, and this can be Virginia focused, or if you want to go further than that, you're welcome to as well.
Yeah, so can you hear me okay? So yeah, I mean, I'd say the same thing, with as a geological survey, all of our data is public, and I encourage people to really dive into that. I'll admit, before I came to work for the agency, I didn't know half the data existed there. So, and I worked in environmental consulting, so it was very poor on my part. But so it's just, there's a lot of data wealth out there, and understanding where the gaps are is very important. And I think the seafloor mapping exercise was really good for that. But also understanding where we see some of those, weird anomalies, like what's going on with that hot spot around the Chesapeake Bay entrance. That data was collected maybe in the 80s or 90s, so maybe we should do a little more follow-up on that to really understand everything that's there, the habitat, sediment transport, and yeah. So I think I'll end on that. So.
And one quick follow-up go ahead, Laura.
Oh, and maybe this is getting, but I think so. USGS, all of our data are publicly available as well. But one thing David just mentioned. Doesn't always feel super accessible, right? Digging down into these websites, how do you find out what's there? And even though, okay, I'll say USGS, we are a data repository, right? What we collect is available to the public, all these things, but it's hard to always make it accessible. And I see Marco, I'm really appreciative to Marco, NROC in the Northeast that have these data portals that are informed by many end users of what the needs and wants are, being able to help serve up that data where some of our agencies just, aren't as equipped in that way. And also, I just want to give a shout out to ocean state management plans, or state ocean management plans as another way of pinpointing where should we go next, what are the entities, players involved, and that's how we should spend our resources.
Boy, we love to hear that. I'm going to go ahead and open it up because I have these people's email addresses and I can bug them all day long. How do we? There's a lot of hands really quick. So
we have one question here from early on.
You guys facilitate that.
Yeah, thank you for the presentations. I'm Dave O'Brien with NOAA Fisheries. So a question for Laura. One of the slides that you showed, the birthday cake slide, it seemed like a lot of the concentrations of these heavy minerals were well below the surface. You had a scale of 8 meters. And so I'm concerned, or I guess I'm curious, not concerned, regarding extraction. I mean, that seems to be a different type of process than we're familiar with in regards to sand mining for beach nourishment. Can you speak to that?
So, the birthday cake. The birthday cake slides, these seismic reflection profiles, they don't show you where minerals are. You see layers, right? And those layers of material, it can be mud, it could be a shell layer, it could be sand. But why you see, like how we can see the little U's for the paleo channels, it's based on a contrast in the material. And so if you have mud above sand or gravel or something, you would start to see a band that I'm saying is a piece of the layered cake. But we can't see grain size with that. We can't see minerals with that. But what we do is it gives us an idea of the structures, right? And so in this case, I've talked about that rivers, right, are important conduits for bringing these minerals from the inland. They might not hold the concentrations. They are conduits. And so if I were perhaps prospecting, I'd want to know where they are. But they in themselves may not be the places that have the highest concentrations, and you wouldn't know it from the data that we've presented. So those are deeper, 8 meters deeper than what you mentioned that is usually explored for sand for beaches. Usually that's at the seabed. And so now there are some paleo channels that are right at the seafloor. But again, if people were to look at prospecting, they do some other sampling or something in the sorting and the X-ray examination that David said before you started to think that's where the resources are. So we don't know where all the minerals. Another thing we don't know where all of them are, but that would be a device.
Thanks.
And I'll add on to that. The data points that were shown, those color-coded points, most of those are surface samples or vibrocore samples, so they're within a dredging depth, and the study we did for Sandbridge was based on vibrocores to characterize that for beach nourishment. So it is dredging would be the mechanism for that, and then onshore these deposits are just excavated with a bulldozer.
Hello? Oh, can you hear me all right? Jordana Cuttajar. I am a resilience planner with Delaware Coastal Programs, and I wanted to thank you, Laura, for the visuals and to your attempt at making geology more accessible for non-geologists like myself. I'm thinking of this as a biologist, as someone who studied water quality, and so my question is really about what are the data gaps in terms of habitat, ecology? Does USGS do anything to coordinate with other agencies to try and co-map these areas? Because if we have a great picture of the sand, well, it's not just sand down there. What species interactions are we missing? And I know NEPA gets to that at some point, but if we don't have a holistic map, I do have concerns about that.
Great question. And so I would say we do have some biologists and things at USGS, but particularly in our offshore continental shelf area, the type of the component of habitat that we most help with is the abiotic part, the part that's not living. Like, is it rocky? Is it sandy? Is it muddy? But we want to be talking to the groups, the other scientists about what's important there, what are they looking for there, and we'd be looking for biologists and ecologists with expertise, right? And we would be, perhaps making a map of, we think it's rocky here. Okay, there's not much rocks down here. Where I'm from in Massachusetts, rocks. But sandy, these types of components, but working with and hoping experts have like, oh yeah, that's that's where the mahi-mahi live, or like to swim around, or these things.
Yeah, and I guess, based on what Kerby said with an expected RFI soon, that might be the kind of thing that you could funnel up through that, those kind of questions. How will these things be evaluated? What kind of data will be made available? I think that would be a good way for states to respond to those.
There's another question up there.
Yeah, Connor Reel. I am the Natural Resources Manager for the Upper Mattaponi Tribe. While I appreciate the economic value of the heavy mineral sands, you identified the paleo channels as ancient river systems and former landscapes. From an indigenous perspective, those aren't just sediment features, they're places where people lived, traveled, and built relationships with both the rivers and each other. When are tribes being brought into the process during prospecting an area ID? And once areas like these are recognized as culturally significant and should be excluded, how is that determination carried forward and actually protected through leasing decisions? Because if these places aren't recognized early through meaningful collaborative consultation, there's a real risk they're only considered after decisions are already in motion, and at that point, the opportunity to truly protect them has already been lost.
Do you want to take it?
Yeah, I think I can take that one. So the tribes. Thank you for the question. That's a great question, and I know that's something that's on everybody's mind, not just in this region, but in every region. The tribes will likely be engaged throughout the entire process, and one of the most notable stages of that will be when we issue the RFI. That's not just we're requesting information, you have to come to us. We're requesting information, now we're beginning our external engagement process and actively seeking the information, not just passively seeking it on a digital platform.
Yes, good morning. Right here.
Yes.
Thomas Rupert with William and Mary. You presented on the potential co-benefits of separating the heavy versus the light sand as another way of potentially providing some a larger economic window for local governments to do beach nourishment. I understand there's a lot that still needs to be understood to see if that's a viable opportunity. Has there been any examination of whether or not separation of the light versus the heavy has any impact on the quality of the subsequent beach nourishment?
Bowen might have done some studies into this, but as far as, are you kind of alluding to if you separate it and then you put that remaining light fraction on the beach after the fact? Yeah, so, yeah, and I know there's been some questions with that. I mean, kind of taking a step back, you're pretty much separating out these minerals that are already there. So I guess you could have a lighter sand, if that maybe is more desirable for a certain beach. I can definitely see, their impacts potentially to like nesting and things like that for some of the animals. We haven't gotten to a point of really examining that, but that is a question I think that's maybe, trying to be looked at into more detail. But as far as from a geologic perspective, yeah, we haven't. I think the idea behind a pilot test is to do exactly, to understand that by doing monitoring. So if you were to do a simple pilot test where you maybe had a plot on a beach, you could do this, and you could separate those heavies and add that lighter sand there, and have an established monitoring schedule. Not only testing geochemical parameters, but also the biology and things like that. I think that would be probably the best first step to kind of do like a micro scale type study. So.
Me first or Laura first? Okay. David, you had provided some commodity price, right here, commodity price estimates. Could you just provide a reference for what those numbers really mean?
Yeah, that's a great question. So the USGS publishes a minerals commodity summary every year. So they update it in January. It's basically for the U.S. export and import data for certain commodities. So that data came specifically from the U.S. Census Bureau. Every time something is imported to the country, they have to keep track of tonnage and things like that and what it's valued at. So basically it came from the USGS report, which is, publicly you can download that. And then those numbers come from the U.S. Census Bureau. And those are basically, as I mentioned, they're assuming like 100% of that material brought in. So.
Thank you. I think the bigger question I'm getting at is those were some pretty big numbers. I mean, based on the price to extract those minerals, does that seem worth it? Is it? a good profit, a huge profit. You know, that's kind of the reference I was looking for.
Yeah, I mean, in the onshore environment, you know, they have really well-established methods of doing that. But when you get offshore, you know, how does that look? We haven't reached that point yet. And then also, one of the higher price stuff like zircon and rutile, you know, those are occurring at least in these offshore sands at 5% of that 0.85% versus 40% of that 0.85%. So ilmenite is much more of a more common mineral. That's kind of the target. And then on the onshore deposits, zircon is more valuable, and it's a higher percentage onshore, but a lower percentage offshore. So maybe the economics will play out a little differently with that. So
I think we could do probably 2 more.
We have Laura over here.
Hi, Laura McKay, retired CZM program manager. So happy to be here. Just a quick question. Do we have the paleo channels on the micro data portal, Carl? Oh, that would be so cool to get that on the portal. And then the other question is, when you're taking those core samples, is there anything in them that could help us understand where or whether any ancient human civilizations had been?
I mean, I can speak. So the core samples that I looked at were, as I mentioned, they were archived from an investigation looking at sand resources. So, I mean, the goal behind that was, you know, grain size and more physical parameters. I can't speak particularly to like archaeological evidence in those cores. Maybe, do you have any insight?
So from core samples that were collected with bone in this area, there were no artifacts found, and it's very rare. I mean, the ocean is big, land is big, it's a needle in a haystack, and everything moves around in the ocean. Off in New England, off of Maine, there have been, you know, at times there was a stone cut tool found in what looked like a place that would have been preserved as the ocean was coming in behind a gravel beach. And there has been, I mean, most artifacts have been found by fishing dredge, the scallopers. And so as Dennis and I were talking about, there's a famous find at the edge of Norfolk Canyon. And so that's generally where that information is. What you will find in a core potentially is if it's, you know, an indication that, okay, this used to be a beach, this used to be a marsh, these types of things.
Okay,
Thank you.
Let's do one more question. Who's got a burning question?
Hey, thank you both, you three actually, for the great presentation. I'm Jordi Izio, I'm with Fugro, and I have a question about data acquisition. We show a lot of different data sets. Thank you for explaining them for the audience, and I think it was very clear. We saw some sub-bottom data, we saw some other seafloor mapping data, but you also briefly touched base on using geochemical signatures to see if we could identify these heavy minerals. Does it open the door to other data acquisition technique? Are we considering more in situ testing and things like that are not maybe the most used in this area?
I can speak a little on the geochemical component. So this was you know, a screening method that we designed as part of this capacity assessment, and it was, you know, we used it on already collected cores. So a question we wanted to answer was, you know, could you use this screening during data acquisition on a boat, for example? There's limitations with that, particularly in, you know, in moisture content and things like that. So the method does better with, you know, dried, homogenized sediments in a more lab-controlled setting. So I think if you were to have kind of a space designated that you could run this simple process, dry out samples, and kind of as you're collecting data and do it that way, you'll have better results. But I mean, you can run it on freshly collected cores. You're just going to have to know your assumptions that your data might be skewed or it's more relative to different comparisons. Like you may be able to see higher concentrations, but you may not. It may be kind of skewed or diluted based on the water content. So I think there's And we're doing this with other projects for in situ cores as well on land. So I think there's been a lot of work on land. And there's been a lot of work on dredge materials using XRF just to look at contaminants. So I think it's an evolving science. And I think it's, still has some tweaks to figure out. So, yeah.
Well, let's give a good round of applause for our panelists, David and Laura, and for Kerby. These guys are being around today, so please catch them on a break if you got more questions, and do keep an eye out for that RFI if you want to kind of wade into the formal process and really help us understand the questions that remain. And thank you guys very much.